all the things that you do. But at the same time, he just graduated high school less than a year ago, and we're extremely proud of him. And I thought, the best thing is to show that example of how it all works out, and he is the living example, so make it happen.
Cool. Yeah, I'm notoriously long-winded, so I'm gonna try to keep this short as possible, giving you guys my story. My name is Jacob Sanchez, 19 years old, just graduated class of 2017, Rockland High School, Dan Frank's program. And back when I was a freshman, I moved there to Rockland from a place called Manteca. Didn't know what I was gonna do there. So once I moved to Rockland, I was like, don't know what I'm gonna do here either. So but I got there freshman year, all manual machines, cheap Chinese CNC or manual lathes, mills, like 2 of them. Nothing else. Didn't know what the word CNC meant. Didn't know that this industry was even out there until middle of sophomore year, junior year. We got these TM1Ps from Haas, and we still didn't know what to do with them. We had SolidWorks, Mastercam when it came to design. There was Inventor on there from Autodesk, and I said, hey, how do I use this? I don't like Mastercam, and my teacher didn't know either, so I taught myself Inventor. And I just started designing, programming. I'm like, oh, this is fun. I was like, is there anything we can do after this so I can get the part? And he was like, I don't know. We didn't know how to work the machines. And a employee from over at Tie-In, Stuart, who's my mentor, he came in the middle of my sophomore, going towards junior year when we had our machines. And he said, hey, we have these 10 building blocks we want to try out. This curriculum that we're working on, we want to get started. We want to see what works, what doesn't work. Can you guys do it? Sure. So 1 week he wanted us to make this rectangular block, and he just wanted us just to make the block. We were sophomores, we didn't understand. So he comes in the next week, he's like, all right, let's see what you guys got. We finished the part fully. There was a 0.5 depth pocket, there was 6 or 7 holes, there was all these tabs, and he was just amazed that the curriculum worked that good, that quick. And after that, we made our first part, we made chips, it took off from there. Junior, senior year, we were doing stuff. We went to William Jessup University for seminars, we went to Skills USA, we were doing all these things, but we didn't know where to go after high school, especially me, because I was the oldest out of the program. So I'm a senior, not knowing where I could go with what I've learned, and my counselors and administration didn't want to help me. They didn't really believe that I was going to go anywhere unless I went to college. And I'm like, I'm telling you that I know if I go to college, I'm not going anywhere. And I love college, don't get me wrong. I support colleges. I part-time teach at Sierra College. When they first started up their program, I did H-Tech there and ran a machine, did demos, all that stuff. It's just I knew that I couldn't do college. I just couldn't. And nobody wanted to help me out. There was one counselor that she wanted to help me, but she didn't want to get in trouble by not telling me to go to college. And after I graduated high school, Tying in the team, he said, hey, I will never forget, I was an hour and a half away in Manteca on my summer vacation, visiting family, and I got a text message, hey, do you still want to work with us? I said, of course. And he's all right, come down with your papers right now, we'll hire you. I drove all the way back there in traffic, man, I got there real quick. And I started working that Thursday. And ever since then, I've been there for 8 months now. I'm programming all the time, working on my first 5th axis part. I just did this Tie-In 53 part with these 3D multi-axis ball tracking down. The multi-op where on the inside of it there's these O-ring grooves with different depths and more ball tracking on the sides with wall radiuses and just different stuff that I've had to up my way of thinking, up my way of programming to make this part. And I actually got to make it when the CTE state director, is that who visited our shop, yeah, was there, and she got to see what this academy can actually do for students. You know, for somebody that didn't know what he wanted to do in life after high school or doing high school, to finding out, hey, I can do this, I can make parts to help people, help my community, and help education. That's why I got into this. I love helping education. that's what I want to do for the rest of my life when I work with Titan. I want to go help educators. I want to teach the teachers. I want to make sure everybody has the tools that they need to be successful. And so that's why I just love, I got help out John Fuller from Roseville High School. We've just got back in touch, and I'm going to start helping him again with programming, just getting the curriculum all set down. And I think what you guys are going to see today with the Academy is really going to change you guys. So I'm going to hand it back over to Titan.
Yes.
All right.
Yes. Go ahead.
Do you think it helped you learning the program with your instructor? You learned it better?
Yeah, because Frank didn't know anything about the program either. This was new to us totally. These parts, how to make the parts, we learned together. There was points where Frank didn't know how to do something. He would come to me and I would say, oh, I've actually been messing with that. I think we should do it this way. We would go out, try to be like, oh yeah, you're right. And then now he knows that, and then I know that I can learn things on my own and help others even though they're older than me. You know, so the age doesn't really matter. It's just I've always been dedicated to pushing myself and just knowledge in general.
A quick one for you. Did your high school counselor, was the machining course your choice, or did you just kind of get stuck there?
Oh, when I was a freshman,
Yeah.
and there was just the manual machines, I had to pick an elective, and I didn't know what else to do. I didn't want to do culinary, or actually, I didn't get culinary, so I got put in ESD. And then I wish I was wearing it now. I have this ring that I made. It was the first thing I ever made on a manual lathe, and I put these lines into the ring, and they're each 40th out part. That was the first thing I ever measured, made sure it was perfect, it was beautiful, the shine on it, and I wear it every day. I've had it for 5 years.
Is that it?
It's something like, that's not mine, but yeah.
That's mine.
Frank scared me for a second.
He was at their house, man.
It looks just like that. And that was the first thing where I was like, wow, I can get into this. And then somebody showed me a CNC. I was like, wow, I can really get into this. I started making my own race parts, actually. In my math class, I would draw, just after test, draw, and I would ask to leave the room to go to the engineering room to get my design.
What math did you take in high school?
Took integrated 1 and integrated 2. So
I think that's really important because it appears to me that most people think that someone that needs to go into manufacturing must have Algebra 2 and trig, and we got to dispel that. That's ridiculous.
I was terrible.
And yet, but you know Cartesian coordinates, you know absolute values, because that's how you write G-code.
Yeah.
And so
It was applicable math that I understood. It
that's
wasn't math.
exactly right. And we got to dispel that whole idea. That is just stupid.
Tell us what you really think.
That
We've been talking.
For your CNC, are you starting out with, so you have 3 or 5 axes for school use?
Oh yeah, 3. I definitely started out with 3.
It's like 5, yeah, but I mean, are you doing 5 axes in high school? Anybody doing 5 axes CNC in high school?
Are you kidding?
Well,
There- there-
No, they're doing it.
There's a bunch of schools that have 5 axis now, a lot of them. And
In high
you guys are
school?
starting? We're starting. So they're starting, but the truth is every time you hit the floor, they're not actually running because there is no 5 axis advanced curriculum. So whatever you have, you guys are figuring out on your own, and it depends on their experience. You know what I mean? Whether it's going to be top notch or, so we actually have a 5 axis program that's going from, just making it super easy all the way to complex. And then it's not just aluminum, then you step up to harder metals, steels, titaniums, and those things. But then we teach you that 5 axis is actually as easy as 3 axis. You just need the right teacher to just show you the little bells and whistles. What a man, right? Somebody just asked me, like, what about you going into education, you get rid of you guys? And I'm like, no, they're all multitasking machines yesterday. And I'm like, you want to go on a field trip, man? They're like, machining has field trips? So I'm like, yeah, let's do it. So let me explain something. The parts aren't just parts. these are the building blocks. It's our easiest series. The part that he talked about, the first part that we basically gave it to the school, it was all the way to the left. It's the Titan 1M part. The cool thing is now I've seen pictures and I have 1 million photographs of kids 6 years old, 8 years old, 9 years old, 12 years old that have actually designed, programmed, and CNC that part right there, and in all over the world, and it's just changing lives. And what happens is they just pick up a little bit, and then by the time these 10 parts are done, then they basically understand the mechanics of manufacturing and how to actually select lines, and they can almost make anything. Then it's just about an experience of like, what tools do we need, what tools are out there, what's the surface foot, chip load, all the different in particulars. But I wanted to just talk a little bit about the why we actually and how we design these parts. So one thing, when you come to my shop, anybody who's been to my shop, one thing that you quickly realize is the assortment of parts. We have 1 million parts out there, and basically they're just on display from all different industries. And because of the sheer variety and complexity of parts, and because of the experience of seeing and working with the top engineers in the world, we just understand the gamut of parts. So we've, as a machinist and a problem solver, working with my team, especially Billy Boyce right there, who's an amazing designer, who gets sick of me sometimes walking in, hey, let's go do this, hey, let's go do that. And like, oh, can you do this? Oh, you're done? No, let's add this, let's add that, let's add this. And we've been having a blast making these parts and stuff. But I just wanted to go through and actually do a little explaining. So, actually, oh, there's Jacob again. So so this is our website. It's academy.titans of CNC. Basically, every month that goes by, it gets a little bit better, a little bit quicker, and we just keep putting content, keep R&D, keep making things better and figuring things out. And as people and teachers make parts and give us, their say on what they liked and didn't like, we're not being like, hey, too bad, that's how we did it. We're just tweaking. If we believe in what they said, we're actually just constantly tweaking to make it better and better and better and stuff. So that's the Academy online. It's free for everyone. Now, this is what I was talking about earlier, is basically, the system, right? So every operation, there's the Titan Trilogy, as we call it, where you actually learn how to design the part. You actually design the part, then you program the part, and then you actually CNC machine the part and hold it in your hand. And basically go through the steps. Each one has a video that teaches you step by step exactly what you need to do. When it comes to the CNC, we actually we step forward, and we don't teach every video how to stone your table and every video how to indicate your part, but as you go, it'll tell you you have a checklist that says, make sure that your vise is on, indicate your vise, stone your table, do all the different things, and you just go through and check everything. But at least once, we actually show you how to put your stop on, and we have videos to support everything, and we put it in order. All right, so videos, so whether you're a teacher that knows machining, you got a little bit of experience or a lot of experience, there's no way that you can go wrong, because if you follow the video, and you can basically make any part. Somebody was talking about SolidWorks. I have SolidWorks. I spent a lot of money on SolidWorks. I have Mastercam. I have a lot of different softwares at my company. I actually don't use them anymore, just because I made friends with Autodesk, and this guy Carl Bass was like, why are you using SolidWorks? We're an American company, like we're doing this and we're giving it free to education, and these are our plans, and these are the companies we bought, and this is how we're taking over the industry. And I was like, oh, that's awesome. And if it wasn't for him and it wasn't for Autodesk, I wouldn't be sitting right here, because there's no way that I could have 35,000 students actually machining parts mostly for free, because they'd have to go buy these packages and pay huge money. Prices are coming down because Autodesk came in and disrupted the market. So as Fusion 360, which I chose to teach in, is advancing and getting quicker, it just allows me to hit a massive amount of people at the same time and it's the only reason that the Academy is alive. If we didn't have Fusion or Inventor, I basically would just be machining parts for SpaceX and maybe still making a show, I'm not sure, you know what I mean? But it gives us the platform. When you go into a video, there's something something we've done is to the right. So anybody, you can be on your phones, you can go into the video, and then to the right, maybe not on your phones, but to the right is related files. And basically everything that you need to be successful in actually machining that part or designing that part or programming that part is actually going to be here, and you simply can click it and download it and actually just print it off at your house, at your school, anywhere. So what do we feel is important to actually go with the process of watching the video? First is a curriculum outline. This is going to explain exactly the tools that we've given you and how to use them and the steps in order of using them. And by reading this and trying to make it very simple, remember now, there's a video where I literally tell you, okay, click here, click here, click here, do this. There's a process that you follow, and you follow the process. So I don't need a book to explain things. I just need to guide you in the right direction, and that's what this outline, which has a Rev 2 that's a little bit longer, a little bit explains more things, that's coming out very soon. So this is a curriculum outline that explains how to actually teach and do the course. These are the prints. When Jacob first said that he did a block, one of the things that we did was we actually created 3 prints. So let's not get too excited. Let's just draw the first rectangle. All right, let's not worry about other things. Let's just draw the rectangle. Once the rectangle is drawn and it is to print, then let's just do the holes in the rectangle that we already created. So we're dissecting it and giving you bits that are actually manageable. Okay, so let's just do the holes. Once the holes are done, then we're going to give you the pocket and then the outside pocket to complete the part. All right, so this print is scaled similar to a regular print that we'd use for an outside customer. And you'd see that it has our tolerance thing down at the bottom. It's got our material list. It has our finish call out, and this one is just machined. And the next thing we do is we actually give you a setup sheet. So the first setup sheet has the 5 tools on the first operation. It talks about the cut size of the material, and it actually gives you the instructions of how to actually hold the part in the vise, where your X, Y, Z zeros should be located. And of course, as you zero your machine on your fixtures and your tools, we have videos that teach you exactly how to do that. The second setup sheet would be for the second job. So let me explain something that we did that is straight up awesome. Because we love you. We love you. Come on, like, we love you. We love you. Dan Frank was saying he gets $7 per student. Like money, like $7 per student. Like, he's having to go out and hustle and get free material and free this. And I started asking, like, why are you, like, you're making a cell phone and there's 3 cover and there's 3 people doing it, and they're not actually hitting the button themselves, and like this is all you're making in 2 months? Like, and they're like, we just don't have material. We don't have money for material. We don't have money for tooling. We don't have money for this. And we spent 10 grand on our tool crib, but we don't really know how to use all those tools and how to make it. Our rep basically said, go buy all that stuff, and that's a good starter kit. And a lot of teachers were just lost. So in looking at that, we looked at the building blocks, and we said all 10 building blocks we're going to make from a standard material. So if you have 44 inches, 43.75, something like that, of material of 1x2 6061 aluminum, that piece right there, that's very inexpensive, you can make all 10 parts from a single piece of material, which will help you because it has a similar way of fixturing and holding, although we use soft jaws on the second sides and do different things. It'll help you get through the parts quicker because you're running from the same stock material. So standardized material for this teaching series. Another thing is, let's actually, in the production world, if I have my own part, and I have a series of parts, and I'm running different jobs at different times, but they're all basically the same. Every time I stop the machine from running, I'm losing money. So every time that I'm actually putting tools in, taking tools out, although for education you need to get them the experience, I'm losing money. So I need to figure out how to fixture my parts so I can take this setup that I run every 6 weeks and I can just lock it in place in seconds. And I need to actually load my tools and standardize my tool list. So my tool list, I can just program and call the tools from the list so I never have to replace them until they probe or out of spec and they're just not good anymore, right? So my tools stay, that allows me to just go from part to part to part to part and manufacture and take out the setup involved. That might be a little complicated, but in the same way of thinking, we came up with 16 tools, which was a standard list. So schools are like, oh, I'm going to start a manufacturing program. Oh, I need at least $10,000 to, or $15,000 to actually just buy a bunch of drills and different end mills and different this. And I'm not sure, let me just get what's the standard sizes and what's this and what's that, and let me build this tool crib. And instead, we basically said, you can make all of these parts with the standardized material, and we can make all of these parts with just 16 tools, period. And then when I went to Kennametal and I talked to them, Kennametal said, we basically, because I worked the deal, the art of the deal, right? I worked it because I was like, look, you got to give the education because you guys are suffering from the skills gap. Everybody's suffering from the skills gap, and if you don't give to these schools, your future is in jeopardy and stuff. And they're like, they have to make money also. I'm like, these kids will get out knowing the Kennametal brand that you're an 80-year-old American company. So get them using the tools in the schools, then they come out and they'll buy it for their life if the tool's good and stuff. And it made sense. So basically they took the entire 16 tools, including a $450 face mill, and they basically put it in a kit, and they put it up to, I think it's something like 72% off. It's for $800 you get all the tools and that you need for the building blocks. So that comes with, if you bought it alone, a $200 key cutter, a face mill that you can literally run at 800 inches a minute, don't do it. But it's legit, and all the tooling is carbide advanced tooling. Because in the videos, I'll show it at 4,000 RPMs and feeding at 25 and slow, but at the end, I speed a lot of them up and I go to 12,000. I show that we were at 9 minutes. We made these changes, we got it down to 2 minutes, and that's a difference of 7 minutes because of the way you approached it and because of the tools that you used and stuff. So now with the building blocks, there's a simple kit you can buy from MSC or Kennametal. And it's below their cost, which is pretty awesome. These are all the tools that are in that kit. And every single sheet, the last sheet that you came with, these 5 tools are selected from this list of various tools.
Real quick, just maybe emphasize what
Yep.
you're doing there with Kennametal. That's all inserted tooling.
It is not all inserted tooling.
Some of it is, but
Kennametal specializes in they actually do a lot of mining, so inserts is huge with them, right? But when you look at the top on the face mill, that is an inserted tool. But when you drop down to tool 2, that guy right there. So the first one is an inserted tool where you only exchange the inserts unless your kids crash the machine. That's not going to happen, but you never know, right? So you're just changing the inserts on the first tool, which aren't that expensive. Now the tool 2 is just a carbide 3-flute end mill, a 1/2 inch. And we have a 3/8 carbide end mill, a 1/4 inch carbide. So there's no inserts, it's just a carbide tooling. 16th end mill, 1/2 inch ball mill for 3D multi-axis surfacing, 1/2 inch carbide drill, 1/4 inch carbide drill, 228 carbide drill, 177 carbide drill, 160 carbide drill, 1032 tap, 1/4 tap, 3/8 chamfer, 1/4 inch chamfer, and 1/8 by 1 inch key cutter, which was a special tool they created just for me and this program. So all the tools, answer your question? Yeah. And these are the tools you're going to use in the real world. These tools. When you run high speed, if there's somebody out there running high-speed tools in an extra manufacturing company, either they have their own part and they can make their own price, or they're headed into hard times because high speed just cannot compete. But that's what schools can afford, and it's just a sad thing. So basically, we're trying to give you carbide tooling, and I don't take a penny from this, so that the savings can all go to you guys. So this is when you get to the CNC and you're actually stepping into the CNC. Before you can actually run your part, you need to go down this checklist. Boom, boom, boom. And to the right of it is a video that teaches you every single thing on there. So simulating your CAM program, posting it, uploading the code, following your safety guidelines, installing and preparing the vise and the table, doing the parallels, deburring the raw stock, installing the left-hand stop, installing raw material into the vise. We even teach you how to like torque it at the right spec so it doesn't come out. Things that a lot of people just don't think about. But basically, we just went over every little thing in it, all the way to running your parts 6 inches above at a reduced speed with your teacher there, and double checking everything so that when you actually do go through it, you can actually have success. So by the time you actually run a part, we're not just throwing you in on a CNC, you actually simulated it, you actually went through the process, you got it double checked by your teacher, then you went out to the CNC, you watched videos, you followed instructions, you had your teacher do whatever he did to teach you how to run that machine and stuff. You checked every single one, your teacher went down and checked every single one and watched the tool, the machine actually run 6 inches above the part, and basically watch it do exactly what it's supposed to do, and then you basically make an aluminum part, and so long you followed all the instructions, you're going to be successful, and it's the teacher's job to stop you if he sees a mistake.
So you have these all set up to run within a single class period? Or
Some, no, not necessarily. So a lot of people, some people said it was a 1-day course, 3-day course, depends on the hours and stuff, but it usually takes somebody. What happens is when you run the first one, you're going to take longer. You might take an entire week, maybe even a week and a half on the Titan 1.
But in terms of the actual milling of the components,
Yeah,
I'm assuming you got it set up so when the part is actually being cut,
it's on 9 minutes.
yeah, because leaving something on the machine,
Yeah.
you just screwed up for the rest of the
Yeah.
powering of the class. So it's
Yeah, and every single school is different, so that each teacher is setting it up how they are setting it up. Some guys have 4 hours, some have 2 hours, some have all day, right? Some are only on a Saturday, so yep. So basically, you have to look at the system, and some are having a separate class to actually teach, putting certain things in place, taking them out, having different instructions on it, and then leaving the parallels in so they get each part in at a time. Exactly. So at the end of the day, you got to make sure that your students understand the entire process of everything you're doing. So similar to our job that we do on SpaceX, we clean it up a little bit, but basically we're giving you a first article inspection, FA inspection report. And so a lot of schools will say like, I got a big voice though, let's go! Yeah! Did my mic die? I think so, yeah. Did you guys notice?
No.
Oh, okay. Test, 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 test. Solving problems. Manufacturing. Test, test. That's a little louder. Is it good? Okay, so a lot of people are looking at inspection and they're like, hey, let's like teach GD&T, let's teach metrology, let's teach all these things. Let's sit a kid down for, however many weeks and like make sure they learn this stuff before he actually hits the CNC machine. And basically what I'm doing is saying that is extremely important, but let's actually jump in a little bit quicker. Let's actually have them work off a print, grab those decimals, repeat it, double check it, see the decimals throughout the entire process, get intimate with the part, and then when he gets his operation finished, and he's been saying, oh, we're going 750 deep, actually 760, we're going 500 deep, and he's done all these different things, then you give him an inspection sheet, and now he has a problem because he has to actually fill this inspection sheet out. So now, how do you solve the problem? Here, this is a caliper. This is a micrometer. This is a depth mic. This is a thread, right? So you actually give him a solution to the problem and it clicks in his head that this is how I actually check my part, and you give him instructions at that time. They go down this list, and if he does some things wrong, he or she does some things wrong, you fix it and you do it, but you don't pay too much. You just make sure that you actually have the student sign off at where everything's at, that he checked it, you double check it, the teacher actual, boom, accept, and as soon as you get everything accepted and everything is dialed, then you move on to the next part, and through repetition, the next time the page comes up, he has the experience, he already is going to the caliper, he's already going to the thread gauge, he's already going through the different things, and at that time when you stop and you talk about calibrating, you talk about the different things that you do with inspection, they get it and it clicks. So let's do it in a real world situation, just like I would do it on my floor when I teach my guys. Make sense? Brett, do you approve?
Absolutely.
We're over here brainstorming how we're gonna do this and we're gonna implement it. You got to fire them.
Yeah, it's awesome. So like, these are the parts. So let's just actually go through the parts. So we actually spent some time this week and actually just organized them. Thank you, Billy and Matt and everybody who participated. But basically, this is what we're doing. The print, the three parts up there represent the print. You're building a block, then you're building putting the holes in it, then you doing a pocket. That's the finished part. And for that, we're just showing the first operation. For that first operation, these are the tools. That's it. So when you look at the tool list of 16 tools, you can see highlighted in yellow, those are the tools that you're using. All right? Face mill, then you're using the end mill. So when you go through the process, at the first part is going to take you a week. It's going to take a little bit of time. But then the second part is just like it. It's just a little bit, and it's going to take half the time because you have experience from the first time, right? And you're going to notice that the first part was this big face mill right here that you don't know nothing about, but it decked the top. So now when the second part comes up, and I say go to a face mill because you're following a video and you're copying exactly what I do, then you're like, oh, that's what I did last time, and you do a face mill. And as you go through every single part until part 9, then the first order is, the first tool is always a face mill. You literally, through repetition, start understanding, we deck the top to create a datum, and we start working from there, and they just get the rhythm. And after the 10 parts, they can pretty much make anything, and they just know, like they know, First tool, you use the biggest tool to face as much as you can. Second tool, you use an end mill to basically rub all the material to shape and then come back and kiss it. And then once all that, then you do the intricate details like the threads, the holes, the chamfering, and different things. So we're teaching you a process by doing. Is the first part. 1032 threads, we're using roll taps. When we jump over to the lathe, we use cut taps. One forms the metal and the other cuts the metal. They're two different techniques. They take different drill sizes, and we want to teach you both. So we chose to concentrate on one on the mill side, and we concentrate on the other one on the lathe side, so you learn all of it. So now this part is exactly like the other one. You have 5 tools, right? The end mill's a little bit bigger. That's the only difference. Instead of having an internal pocket, you have open-ended pockets, which basically you're facing, you're roughing, but your finishing operation is a little bit different to actually start and stop your cutter, to actually just kiss and not do too much work, but actually just do what you needed to do. So this is the second part. You got the chamfers on the 4 corners. It's just a little bit different. I actually think this is actually an easier part than the second one. It's a little bit bigger though. Oh, and then this one, the first one had 1032 threads. So you see the 1032 threads right here. Then when you go to the second one, that's a 1/4 thread. And then you start realizing, wait, there's just a million different threads and each one's easy. And if you're on a lathe, all you gotta do is really know the pitch, the ID, the OD, and you can make any thread, right? And so we're just teaching you through repetition. Okay, so now all of a sudden we have a round part. It's still a pocket, you're still facing it with the same tool, it's the same 1/2 inch tool, but now we incorporated that little 16th. So the third part that you have ever done, all these kids are doing, they're actually doing little O-ring grooves where you have to just come down, and we actually just helical right in and we just kiss it, so we leave no lines because you can't have a single line in there, right, for starting and stopping. And it's a 16th, but I think the groove is like I think it's like 70 thousandths wide, so a tiny little, so you're teaching advanced things right from the beginning, but the kids get it because they watch the video. A little bit more tools. We still have the drill, the tap, we're learning through repetition, but now we added the groove, and when you flip it over, you learn how to cut soft jaws that you can basically hold any shape. I could hold my hand because I just have to like cut out the pocket to drop it in and then apply pressure. So we teach you that. And then let's just do different shapes. So this is the 4th part right here. Same thing, you're learning through repetition, but now we added this key cutter right here. So now you're coming down, it programs just like an end mill, but it undercuts the side and actually comes in. So you just follow the video and we show you how to do it, and it's a real live like piece that you actually make. And this is something I would do for Brett or another company, right? So every single thing that we're doing, I've actually looked at, Billy has looked at, and we're like, how do we get somebody to understand how to make this? You know what I mean? And so let's just start doing pockets. Let's just take it one step at a time. See these O-rings? We're just teaching you how to make the O-rings. How do we teach you the things that you need to know? Let's not just do little brackets with holes in them. Let's actually do real techniques that you use for top companies, so you can actually get paid $30 an hour instead of 10, right? Because you're worth something, meaning working for companies like SpaceX and stuff when you got good experience. So now it's the same thing. Now we actually do 4 circles. So now you're using the same soft jaws. So we're back at the 1/4-20s. We were back at the 1032s. Now we're doing a star where you actually step in a few times to actually get that radius on the inside. And we're engraving the Titan Eagle on there. And you're learning engraving while you're facing, end milling, drilling, tapping, chamfering, while you're doing the whole thing. So it's just process, same material. Now we're doing islands. How do you actually get in there and cut that middle one out as efficient as possible? There's a lot of different techniques, and like machinists would do it differently. And of course, the way I taught you is the actual best way, but you guys, but you know what I mean? We made it simple, and we solved the problem, and we just show you how to actually create islands, and then step down with your chamfer and different things. So, but it's the same type of tools. This guy right here, now let's mirror the exact thing we have on this side, let's mirror it on the other side. So now you're dealing with the design portion of mirroring the part, and you're actually dealing with holding it in soft jaws with an uneven, it's very thin over here and very thick over there. And we show you how to actually create those soft jaws and show you how to mirror that thing so that it inspects perfectly on both sides. Same tools, you're learning through repetition. But what happens, through my entire life, I'm almost always using a face mill. I'm almost always using an end mill. Every single program, pretty much, if I'm on a mill, I'm using a chamfer tool to do the edges. I'm always using drills. I'm always using end mills. I got this we have a nice small end mill, 1/4-inch end mill that we added in here, but to do the counter bores and stuff. But it's like, we just keep bringing it forward, and we keep changing the part, but you're using the same toolbox to basically just keep creating these different parts. But we just switch it and switch it and switch it. And after a while, you just realize, wait, all the tools, they don't even matter. Because the only thing that matters is this line right here. Because all I'm going to do is I'm actually just going to click that line. I'm going to tell it a tool, and the only thing it knows is the diameter of the tool. So if it's a 1/4-inch, it's going to offset the center of that tool 1/8 of an inch. If it's a 1/2 inch, it's going to offset 1/4 of an inch. If it's 1 inch, it's going to offset the tool, and then because I click this surface, it's just going to follow the circle around. And everybody's like, oh, 3D is so hard, and it's the same thing. It understands the solid, so as it actually comes up, it understands this contact point, and you basically just say, start here, go to here, step over at 5 thousandths or 20 thousandths, and it basically just does it easy. The problem is, most people who were machining 10 years ago, this is a very complicated thing to do in their minds because the software back then made it complicated, but today you simply click it and you can almost press go and it'll do it on its own. And that's what I'm doing. All I'm doing is basically showing the simplicity in it and saying, don't be scared of it. Let's actually just do it, right? So every single tool, no matter how many tools I can show you, if this was a 4-inch diameter right here, and I programmed around this, it would just go 2 inches off, and it would just follow the process. If this was, say, 12 inches, it would go 6 inches off, and it would just follow it. It's literally that simple. So what we have to do is stop being so like, oh, you gotta learn all these things, but let's just make parts. Let's just go experience the tools. Let's cut some metal. Let's actually get in and hold the part. And like, oh, you actually distorted the part. Let's actually use the torque wrench and actually relax on it. Your surface bend. Oh, your step in. I see a line right there. What can we do? And actually just work the problem. And over time, you end up just learning about the machine and everything because you actually go through repetition and you just get it. Same thing. I did on the triangle part, we did the radial. This was literally me looking at Billy and like, there's some binoculars, man. You know what I mean? Like literally. And like, the story here, Billy actually was a friend of mine. We actually worked on some different projects. He worked for another company. And basically I hired him on the side to help me with some CAD drawing and stuff because I didn't have time and he was an ace at it, so I would just hire him once in a while. And then when I started doing the building blocks, I didn't know I was going to go full into education, but I just said, hey, can you start putting hours and put hours and put hours? And then he was just like, man, Titan, I love you and I don't like working there. Like, I want to stay here all the time. And I'm like, one day maybe. And then all of a sudden I was like, dude, like, let's just change the world and do something here and come full time, and you're just gonna help me design this stuff. And I got ideas coming out of the bag, and you just bring your own stuff and create stuff. And you've been doing that for over a year now, right? How long has it been? Dude, I've been dealing with you for a year, man. Like, I'm just kidding. He's a machine, though, you know? So internal O-ring grooves, cutting the part using the same processes, but actually, and then cutting the soft jaws, instead of just a circle, you're actually cutting the entire shape into it and moving it so the intersection of the jaws is at a good place, and you're making a cool part. And by the time you make all these different parts, you actually just understand the simplicity that machining is just not that complicated. It's just not that complicated. It's tools offset off of lines at certain depths. Each tool has a surface foot and a chip load, which is the feed rate and the speed. And you just have to understand and study the tools, and you gotta figure out how you can actually get the metal off as quick as you can to be as efficient to actually make money. So this part right here is actually no joke, but we make it like easy. So I actually, like, Billy shows you how to design the part. Why is this a big step up? Because it stops being flat, and the entire center is actually round, and you walk up the side. So this is what we do with crazy aerospace parts, because they want all the material gone, and they leave ribs and stuff. And basically, I show you a 3D path to cut the flat on the bottom, to go up the wall, and then to do the top of it. And it's like 3 different systems that just basically show you how to do it. And once you make this part, you can make a globe, you can make your hand, you can make somebody's face, you can do anything, because we just showed you how simple it is. And this is basic CNC, this is basic easy stuff. And yet most teachers are like, oh, my kids aren't ready for that. Just watch the video and watch how easy we make this. Just follow the software, it just makes it happen. Kids all over. I didn't have to say anything. There's pictures all in the group of kids actually making this part right here. Of course, you can't just jump in. You gotta, like, take each step and learn the different fundamentals coming in. And then this right here is like, I'm like, how do I get SpaceX not to be mad at me, but do like a cool ISO grid like we do like on the rockets and stuff. And basically we just took what most aerospace companies do is the honeycomb pattern for strength, and we literally just made a small part, which we haven't really made they're usually bigger ISO grids, and we made it smaller. And if you look at this one, you can see that the part itself is the same, but by the time you get to the third one, it's smaller on that side and bigger. So, and if you look at the bottom, it has islands now. So it has islands, it has the ISO grid, and basically it's tapered, so you're 3D surfacing the whole thing. And now, when I just was at Rockland High School and they completed these jobs, I looked at their robot and I looked at the arm pieces, and they were this part because the kids made the part and then they put it into their robot. Is it robotics first? They actually put it into their robot and actually made it, and now they got grills for trucks and all kinds of stuff. And then I just saw the guys from a school from LA, they're like, hey Titan, you inspired the robot. And I was like, and then I look at the whole flat pattern, and it was the same thing. So the kids saw something they liked, and they're like, it's aerospace, and they just started making it, making all kinds of things out of that pattern. Okay, so you see my post yesterday? Who was in my group? Somebody was in the Facebook group. Did you see the post I put up yesterday? Oh man, you like it? No, I'm just kidding. It was on autism. It was on, we have a kid, a friend of mine I was just like, like autistic students, man, they thrive in manufacturing. Like they're dealing with a machine. It's not judging them. They make things, they get confidence, they deal good with repetition, they do good with computers. And actually as an operator, these kids that the parents think they're gonna be on a couch forever and not doing anything, they can actually thrive in this and stuff. And I have, if I can say it, my son was diagnosed with Asperger's when he was young. And program SpaceX's most difficult parts we'd never even know today. He has a beautiful fiance, perfect credit, and he's the nicest guy that I know, literally. And I have a 6-year-old that has autism, a little bit more severe. And all I know is that he, like this weekend, he came to the shop with me, and I'm just gonna take him to the shop more and more and more, because autism is a crazy thing. It's like 1 in 64 people, and it affects almost everybody in this room. Probably knows somebody that has autism, and this trait actually saves lives, literally. So yesterday I did a post with a good friend of mine who has 3 sons who have autism, and I looked at his middle son, who's like really struggling with. The longest he's ever worked was an hour, and I said, start letting him come over to the shop. And then I went out to Jacob and Tyson, and I said, hey, I'm going to bring in this kid. He's 20 and he has autism, and I know he doesn't have good fine motor skills, but can you just let him job shadow and start putting and taking parts? And then we posted pictures after 3 weeks. Now he's doing 3-hour shifts, and he's using his foot pedal, and he's doing double parts. And Tyson and Jacob have shown him how to load and unload and inspect parts. The first time he grabbed a caliper, like he couldn't get it straight on the part, and now he's inspecting, and he didn't scrap any on. Like, he's killing it. Yeah, doing good parts and stuff. So I did a post yesterday, but this is a cool video, and then my son's gonna actually come up and share too. CNC machining saved my life. It has also changed the life of my son Tyson, who was diagnosed with Asperger's. Recently, I took my son down to this incredible school, a school that is teaching CNC machining to autistic students. It's an amazing program. Check it out.
I met Tyson over 6 years ago. I could barely get a hello out of the guy. He just always had his head down in the machine.
At first I thought he was kind of quiet, and I realized that when he's in his zone and working with such a complicated part, his focus is so strong that whenever you go up to him, he can go through and be able to talk to you and also work with this crazy part with ease.
I've worked with Tyson many years now, and he's a very intricate person. He's very smart, and he's very capable, willing, and able to produce anything that he sets his mind to.
It's really good to see someone have that passion in machining. It always affects others and makes other people want to manufacture. It's pretty strong too. You can pick up a pretty big piece of titanium.
He has come so far since I met him, and now he's programming and running some of the craziest rocket parts that I've ever seen, and I'm really proud of the guy.
The purpose of the project, of the Uniquely Able project, is to facilitate opportunities for uniquely able folks to have successful jobs.
I'm very excited that Titan's coming here. I love his energy. I love his commitment. And then to have Tyson, his son, come for these students to see someone like them and to say, wow, he made it. I can do that too.
We believe in the student population. We want to give them that opportunity that they would not have otherwise.
Just among autism, the rate today is 1 out of 67. It's an epidemic.
I was on the mainland, my two sons were in Hawaii, and I was like locked over here, not even being able to see my kids. At the same time, you know, there was a huge hardship because, you know, I found out that my son had been diagnosed with Asperger's, and I never really dealt with autism. I didn't really understand it. When I saw him, I thought that everything was good, you know what I mean? And he was struggling, and I wasn't there for him.
What is important to get about a parent who has a child who's uniquely able is the first thought they have is, I hope I live one day longer than my kid, because nobody else is going to take care of him.
My son came to live with me, and he didn't want to work. But I said, if you're going to live with me at 18, you're going to work at the shop or work at McDonald's or, you know, do whatever you want to do. But you're going to leave the house and you're going to work. So he worked at the shop and fought me every second of the way.
I remember constantly going to his office and being like, I don't want to do this anymore. I don't like working here. And eventually I got to run bigger parts, more important parts. Just got more interested.
One of their disadvantages in life is a real advantage when you're talking about running one of these CNC machines.
Future CNC experts extraordinaire. What had happened is I had a whole bunch of parts for an aerospace company, and I had the heads of this company telling me that I was making the most complicated jobs. They had to have them right then. So I went to my son and I said, we're going to go trial by fire. I'm going to throw you in the deep end. We're going to make these parts, and through the process, you are going to learn how to program. In a 2-week period, he had to make all these parts. I put it all on his shoulders.
Up until that point, I like to avoid as much responsibility as I could. I figured as long as I was only doing what I was told and pushing the buttons and whatnot, I could get home as soon as I could and wouldn't have to worry about having to program all these tough jobs. But had no choice at that point. You know, I guess I could have argued or whatever, but basically took those jobs on, got the parts programmed.
And it came out beautiful, came out perfect. The following is brought to you by Autodesk. I don't know how that got in there.
I was very familiar with the characteristics of autism, and I noticed that the characteristics of somebody with autism matched the ideal characteristics of a CNC operator. I mean, very simply, you want somebody who's really good working alone. You've got to have somebody who's really good working with a computer and is comfortable thinking like a computer, if you want to use that phrase.
I really like machines and technology and anything having to do with it. And the fact that this is a really more hands-on class just makes it more fun. And I love it already.
I don't have much of like a working set memory or short term, so I store my ideas in physical objects. Making stuff works so much better for me.
You know, I'm pretty much good at computers already, but this goes beyond computers, and it's something, I mean, it's still something I'm familiar with, but at the same time, it's something I'm learning that's pretty much brand new to me.
As long as we look at people through this lens of disabled, they're going to be held in a box, and they're not going to be able to be fully productive and contribute either themselves or society. So we need a new word, and that's why I coined the word uniquely abled.
It is very rewarding, I have to say, to work with these uniquely abled students. I have discovered they are more brain than we think that they would be.
Today, you know, this industry has given him something that not only he enjoys, but it pays his bills. And I'm incredibly proud of Tyson, because when people saw him only on a computer, when they saw him not wanting to do anything or socialize with the world, they thought that he wasn't capable. My son is able to stand there and program amazing parts better than anybody I've ever seen. And he's been there 20% of the time that most great machinists have been, but he has the head for it.
The fact that Tyson found what he's looking for, even though he has like some disability, just speaks a lot of volume. And I like seeing what he's doing. That makes me want to learn about this stuff even more.
Today we're here to present a check to support this uniquely abled project. And
There's a certain elemental connection that happens when people experience this together, and Tyson brings that to the table. And that's why I'm here today, is not only to support this, but express my gratitude for all he's doing.
Here are individuals that we know have the abilities to achieve, but in a little different way, and that we can take the responsibility to figure out how can we package the instructional program that will help them be successful in achieving their educational goal.
Now I'm very grateful I get to work with my pops.
Pops? That's like, how old am I?
But now I enjoy coming to work. I enjoy seeing my dad and working with him. It's great. And I get to make cool stuff every day.
So just because you feel uncomfortable, like this right here is where you can excel, and then you'll realize that I can do anything. I just needed that confidence. I can make an amazing part. I can do it fast. I can solve problems because I'm an awesome individual with awesome talents and awesome gifts, and nobody's like me. I'm special.
Look at that.
Oh man, that's awesome. It just became more beautiful to me.
You should put it on a chain, man.
I know. Like change come from here.
These kids, for their whole life, have been told nobody's going to hire them, nobody's going to pay them, they got nothing that's worthwhile to society. And all of a sudden they're in a job where they could be the best because of their innate way of operating. They're naturally better than you and I. That's pretty cool.
No. Yesterday I was like, you want to go with me tomorrow? He actually like, we're gonna have you speak, and he's like, I'm like, road trip speak. So, you know, I like to, you know, autism has definitely affected my life, and I think that anybody who has a college, has a school, has anything, like, take note on that, because all it takes is a teacher to say, hey, why don't we grab some of these kids with autism and like have them just start showing up and just hanging out and job shadowing, and let's just teach them like simple basic things, and slowly like get them to make something. And literally that little action, you literally can save somebody's life and their parents' life. This kid that 3 weeks ago that I was like, hey, just have him come, and I wasn't sure how I was gonna work out, and like, you know, the parents, when they see me, they're like in tears, because they're like, you don't know what you're doing right now. And then I just found out that, you know, I was thinking about, I was like, well, I can't tell him not to come in. And they're like, oh, the school that he goes to is actually going to pay him to show up. You don't even have to pay him a dime. And he can work at your shop, and it's better than him doing nothing. You know what I mean? And the government's going to pay for it. And I was like, that's awesome. So they got some amazing programs. So think about that, autism. So when you see the building blocks, I think I do a couple of the initial designing of the parts, and then I hand it over to Billy, and I stick with the programming. So I teach you how to program all the jobs and then the machining and stuff. But on the lathe side, I'm like, why should I pretend when I got the master right here? So Tyson, who he's actually doing all the videos. So you see all these lathe parts and rockets that are being made, you know, and you see like this part right here is out of titanium. SpaceX wouldn't quote this to anybody. It's actually off. And we're dealing with tense absolute positioning. And Tyson like made this part right here. Yep, titanium. This one right here is for the Raptor and stuff. Look, it's not 90, it's actually inside like that, and then it's parallel, so it's a full 5-axis, and all the lathe work and everything was done by Tyson.
I think I did all of these.
Yeah, this one, this titanium one right here. So, you know, this is top stuff. So I just brought a couple of parts. We have 1 million parts, but I just brought a couple of parts so you can actually like later on just walk up and take a look at it. And these are actual aerospace parts that, you know, each one, you know, costs some money and stuff, and that we manufacture and stuff. And I don't put them on TV and stuff, but I thought I would just share them with, you know, you guys.
Just so that everyone knows, 1/10,000th of an inch is 1/30 of the diameter here.
Yep. Yep. 0.0001.
So Tyson, when you're working on a part, how do you see the product based on when he's telling you this is what you have to do? How do you connect to that machine to do this kind of amazing work? Because you're doing it like he said he.
I guess it's pretty easy to follow as long as I have got a print or a model of the part. It's pretty easy to plan out like how, like I've got an order that I do all our lathe parts in. And if I have this part here, I know, you know, I'm going to start with the outside of the part, depending on how thin it is, and I've got my, you know, I'll drill it out, bore it out, and the machine makes it pretty easy to follow how I program it, how I simulate it, and making sure that that matches up with what the machine's how it's going to be machined and what the machine says it's going to simulate out, and I make sure all of that matches up before I start running it.
Because accuracy is such a big deal.
Yeah, and usually for really tight parts like these ones, I will machine it a little bit bigger or smaller and creep up on it to make sure that it's perfect the first time, and then once I have got a few pieces going, then I'll usually let it go.
And some of the material, there's, you know, $5,000 before you even cut into it. So there's no making a mistake, right? And stuff. But I think, you know, what we're doing is we're giving you solid models. We're showing you how to design the solid models, and we're showing you that there's a process. So Tyson understands the process because when you've done it 1,000,000 times, it just becomes ingrained. So as soon as you look at a part, you look at what's the tolerances, how hard can I hold it, meaning, and then which will allow me to be, how aggressive can I actually be with it, and do I need to rough, finish, or can I just rough, finish, which of course material is going to move, but if it has open tolerances, it doesn't matter. So now, you know, Tyson's 28, 29, 20. I was like 10, I'm just saying. I'm just kidding. But 29, and it's like 11 years experience because we started right after high school. My second year, after my first year in business, it enabled me to actually go and send for my kids. So my company not only changed my life, but it gave me an opportunity to be a father for the first time. And I got 6-year-old twins and got a second chance. So,
how much flexibility does Dad give you to make your own cool stuff?
He wants me to.
I try to tell him to take a day off. This guy for a year, he won't take a day off. I'm like, you got a fiance, like, you gotta go on a vacation, son.
But we are making some cool stuff with the Academy, and you'll see the rocket series we're working on in a minute. And then we also have a live tooling series that we're going to be doing. That's how chess pieces, which I really like also. So
yeah, so we jumped into education. He actually got his own office instead of having to share an office with some other programmers and stuff. So one of the cool things that we don't actually explain on here, but see, he has a bunch of tools in front of him. So we have, on both mill and lathe, we have a fundamental series, which basically teaches you every single thing that you need. If you can think about it, we're actually gonna make a video if it's good. Like, what is a machinist stone? Like, how do you stone a table? Like, how do you file? Like, how do you deburr? How do you, like, put things on the table? And what is a 1, 2, 3 block? You know, what's a dial indicator? How do you probe? How do you manual? We're basically making videos for everything, and then we put them in playlists like music, so that you can just make your own playlist and tell your students, just go through all these, and once you're done, you'll have a kind of idea, and then I'm going to show you how to actually do it in the real world. But Tyson actually goes through every single tool. So we have another kit here, it's for the lathe, and he basically has videos on every single tool, and it teaches you how to put it into the machine, how to put it into the turret, how to actually screw it on, and then how to actually zero it and probe it, and put the inserts in, and why you do these things. So he takes you through every single process. So I'll go through the different parts on the lathe. We're backed up on time, but we'll just kind of go through it. So this is the rocket, so it's 10 different pieces. And you basically, a kid or a student makes all 10 pieces, and then basically assembles it to create this rocket. And if you actually look at each individual piece, like, start looking, see the one over there with the O-ring on the top, and this has an internal O-ring and different threads and lefts and rights and different things. So there's a lot of different things going on with this part. So we're just going to go one by one, and I'll let Tyson talk a little bit about each one, just brief. So same thing, this is a tool list. Those are the 13 tools. These are the tools for that specific part. Go ahead, Tyson.
we got 2 OD tools, one for roughing, one for finishing. Groover for the thread relief. A threading tool to put the OD threads onto it. And then a part-off tool to do the end of the parts. This part is the nose of the rocket. It's going to be done, it's done all at once. So it's actually kind of a tricky part for a first part, but after that, every part after it becomes pretty easy. And on a lathe operation, because it's all circular, you're only doing circular parts. So it's all very similar between every part in the rocket series.
There are different tools, different radiuses.
Yeah, you have different radiuses, different tools. This part has an undercut that you'll be doing on that curved surface on the back end. So it's actually facing out of the machine where the threads are. And you do the threads first, then you do the undercut on the back there, and then you use your part-off tool to put a little corner break on the end of the part it off.
Completed in one operation.
So this part, the 85, it's a little bit simpler than the last part, but it does have it has a groove on the back end of the part. It has a bigger thread on the front, so it's similar to the last part you just did. But you don't have to do that curve anymore on the back. You just part it off at the end there, a little bit bigger, and then you have a second operation, which you can do later, where you put the internal thread with a drill and a tap, and that thread that you put in on the second op will screw into the first part that you made.
Yeah. So on the back side, there's a thread that you can't quite see. And he's teaching you at a single point, and he's teaching you like techniques that are really hard to grasp. Like making a solid model that's a thread and then putting it into a threading cycle and then having to actually cover the threads to actually get the cycle to work. So he's basically telling you the secrets of the trade and how to make it easy.
And for the first part, the undercut cycle was a little bit tricky, so teaching you how to do some of those tricks with the part off tool and whatnot. This part doesn't have a thread. It slides on to the last part. It slides onto the shaft of the last part we did. It does.
The shaft right there slides over that one.
Yeah.
And you can see that a whole shaft right there has disappeared in the rocket.
And this one has a O-ring groove in the middle of the part. You can't really see it on that angle.
You can just see the light, that dark, like inside it. But, which is real world. Like this is stuff that we do for aerospace companies.
But if you're doing all the Op-A parts first, this will be the first part that you drill through, and you start doing internal work now. It's very similar to OD work, but now because you're doing a round part, you have to watch clearances and making sure that your ID tools don't hit the backside of your tool, that you're not going too far out. And same thing with the groover, making sure that you have enough clearance for that grooving tool to put the ID groove in without backing off too far and snapping the tool. The outside work is it's all similar to the last two parts you did. This one also has an undercut, which you did on the first part. It's just a different shape.
The last one had a big radius when it came. It was a full radius, and this one has a much smaller radius in that V section. You can see the tool. The tools he uses certain roughers and certain part offs are the same. Changes up on the taps. Now we're using cut taps, not form taps. Go ahead.
This part screws in. It has two threaded holes on both sides. You put one in on Op A, one in on Op B. It'll screw into it screws into both sides. So the previous, not the last part, but the part before it, and then the next part will thread into it. And this one now you have OD grooves, lots of them going, I think about 6 of them going across the part. And now instead of using a full radius tool like you did on the second part, you're using a flat groove, I think it was a 118 wide, no, 63 wide groover. And yeah, your 2-op part.
And one of the cool things is like, if you just have like a 5-seat collet in your lathe, you can basically just put 1-inch diameter, it's standard. So 1-inch diameter 6061 aluminum, which is just a standard anneal aluminum. You can make every single part from the aluminum, so we're solving problems.
Yeah, every single part in this is made out of 1-inch aluminum. Yeah,
that's cool. Left, right.
Yep. This is an identical part on both sides of it, so it's a symmetrical part, but that round piece in the middle is actually a little bit tricky, at least for a beginning operator or beginning programmer. So I think I do most of that with a full radius groover because of the 2 grooves next to it. But yeah, it's got a thread on both sides, so you machine as much as you can on Op A, you leave it a little bit big for Op B, and then later on you'll flip it around.
Same thing?
Yep, so, very similar to the last one. So you can see you're using the same kind of techniques on every part in the series.
The shapes are all changing though, and that's the same thing with any part, whether it be this part or this part, and it's the same thing like a mill. You're touching a surface and basically telling it to take off the material and just to follow that surface.
And by the time you start making a lot of by the time you've made your 4th or 5th part, because these all screw in together, you're starting to get a little excited because you can see you're making something.
And I know, and people have actually offered money for these rockets, and I tell everybody, don't sell them, don't sell them. Like if your kid, like your student has a rocket, that's something to be proud of, and you can't buy that, you know?
It's also a resume.
Yeah. So we have he's laughing because we had a briefcase. So I have like a nice briefcase. There's a video I put up on LinkedIn and on Facebook where I talk about, you know, a shop like mine, like legit machine shops, they don't care about certificates. They don't care about pieces of paper. They literally, I don't even look at it. I like that you give me something, but what can you make? What can you make? Because at the end of the day, if you come in and you walk in with a good attitude and you dress good and you just like boom and you're like, I actually programmed this and I did this, this, and this, and I saved my time and I did this, this, and this, and like boom, I'm like, you got a job, period. So a lot of people now, you know, there's a lot of people out with certificates and kids and they're so frustrated because they can't get good paying jobs, and so we're just trying to up the game and stuff. And there's certain people that do that where because of our presence, we're pushing them to get better. You know what I mean? So I'm not gonna mention names, but there's somebody that I'm super disappointed in. But because I'm disappointed, now they're going back and trying to fix things and do things and trying to make it better. So that's a good thing.
And everything you're doing in this series, you can apply to making an actual part here. So the same kind of technique you're doing to make the groove passes on that previous part that had all the little grooves in is the same kind of pass you're doing to make these grooves on this part.
Then you call in a Kennametal or another tooling company and say, hey, what's your best groover for this size? What's your speed? What's your feed? How do I run it? You know, can you guarantee the tool? And basically they tell you and use the same techniques to do it. Whether it's 4 inches or 2 inches or 1 inch, it really doesn't matter. By the time you make this whole rocket, you can basically program almost anything because you got the thought pattern. Go ahead.
So 90L, this one is tapers downward, but it also has these rounded grooves through it. And then same as the other parts, you have a OD thread on one side. You can't see it on the other end, but you also have a ID tapped hole on the other side. So all assembles together, and I think this one uses full radius groover. So you're doing some undercutting with the OD tool, but you're also using the groover to put in those rounded grooves on the outside.
When you get all these tools in the 13, so that's this one, Kennametal also, and you can go get them from anyone, but you're gonna pay more than twice as much, and that's just period. So this thing's like $1,000, and it has all of those tools. And if you just go buy a lathe and you have all of those tools, you pretty much make a whole bunch of different parts. It's just a perfect starter set and stuff, and you get it at a huge discount.
And I actually use a lot of the tools from this kit. They gave me some of them to sample out when we were picking out when we were deciding what tools to use in the kit. I use the same tools on other jobs that we do. So the same inserts, some of them you can ask Kennametal later if you need different ones, but it's all tools I'm still using for actual jobs.
So kind of blast through.
Yeah, and you can see this one is a very similar part to, I think, the second part that we did in the series. It's got a larger groove, so we can't do it in one operation this time. So we turn as much of the outside again, and then we flip it around, put the ID thread on the other side, and turn a little bit on the outside. The op A's on all of the parts are very similar to each other as far as how we're holding them. 1 inch material, I tell them to stick it out about 2 inches or so. And then the op B, I have a op B setup sheet which I tell how far you need to stick out the part and how much you need to hold it to do the second op. This is another washer type part that slides onto that last part that we did. This time the outside is round. It's another part with a rounded outside in between those two in between those two grooves, it's actually curved. So it's using a technique that we did on the larger part, the symmetrical part that we did with the rounded middle. And it's another part, doing it in one operation, drilling, boring, and then parting off.
So let me say something. The ideal setup for your kids is to have one computer, 2 screens, and headphones. And with the 2 screens, they basically watch the video, have the CAD cam right here, and I think adults' average time on the internet and on social is 2 hours a day. For our kids, it's 9 hours a day. So they're used to learning everything on video. They get it. So they simply, it might seem complicated, but then there's a video by Billy that shows you how to draw it. All you have to do is copy it, and you do that by literally just listening to it, letting it go a little bit, and then pausing and copying what he did on your screen, going back over here, playing, pausing, copying, playing, pausing, copying, and you basically just copy. So there's no, like, you don't have to figure anything out because we teach you exactly how to do it. But by the time you get to the 4th and 5th part, the kids don't listen to the video anymore because they already understand, oh, I'm gonna just do this, and I'm gonna do this, and I'm gonna do this, and they just start killing it.
Yeah, and we now have videos that I put up for how to program the parts, which I was super nervous about putting up because it's going online. But we actually had someone in the Facebook group who went through each of the rocket parts, and I guess he didn't have any lathe experience before he bought one of those rocket kits, and he's made them out of aluminum, and now using the same techniques that I taught him how to machine out of aluminum, he made another rocket out of stainless steel.
The same tooling, not knowing that they were meant for aluminum.
He forgot to check that
they were, yeah.
But he managed to get it through, so.
In our engine.
So you can see the last part isn't a joke. It's got that same undercut in the middle of the part. It's got a little bit of tighter, those outside ribs on the outside aren't very easy to make. We come by with a groover and one of the OD tools to make them. On the back side the angle you can't see, we have a face groove. So a few of these parts, we have face grooves on here. Those aren't easy to make. So the last part you're doing, you have face groove on it, tapped hole on the other side so it can assemble to the last part on the rocket. And that whole inside on the front of the rocket is curved on the inside.
So we can hold our questions, so I can dismiss you guys for lunch, because we're running a little bit over, but it was really great stuff, so it's very interesting. But I'll let you say whatever you guys say, and then I'm gonna herd you guys down the hall and outside to barbecue, and if we get close, you'll just bring it back in with you. But it's a nice day.